So in this video, we're going to do evaluate trig function using reference angles. So in the previous video, you learned how to find reference angles within each of given degrees or radians. But now, when we're evaluating trig function, first we're going to find reference angle and then evaluate with the trig function, sine, cosine, tangent. Those are the three we're going to mainly focus first. Now, eventually, you'll be able to evaluate cosecant, secant, and cotangent by following the reciprocal function rules from 4.1. Now, here, I label out the exact values for 0 degrees, 30, 45, 60, and 90 for sine, cosine, and tangent. And then over here, I label where the trig function are positive. So for A, meaning sine, cosine, and tangent is positive in quadrant 1. Quadrant 2, only sine is positive, the rest is negative. In quadrant 3, tangent is positive, the rest is negative. Quadrant 4, cosine is positive, the rest is negative. Alright, so let's take a look at our first example, cosine of 120 degrees. So our first job is to find the reference angle. So we know that 120 degrees is in quadrant 2. The reason is because 120 is less than 180, which is right here. So 120 is in quadrant 2 again. So the rule for quadrant 2 is 180 degrees minus our given angle, which is 120. So that's 60 degrees. So our reference angle, angle theta prime, is 60 degrees. So that's our reference angle. Now, we're going to use that and evaluate the trig function. So instead of cosine 120 degrees, it's now going to be cosine of 60 degrees. So, now, once you memorize your exact values for sine and cosine, then you should be able to write out the exact values. Now, tangent is fairly easy. Now, remember from 4.1, tangent, the definition of tangent in terms of sine and cosine is that tangent theta is equal to sine theta over cosine theta, which you will see again in chapter 5 for trigonometric identities. By following this definition, you will be able to find the exact values for tangent for the 5 degrees, 0, 30, 45, 60, and 90. But here, let's go back to example 1, cosine of 60 degrees. So cosine of 60 degree, we look at cosine and then we go to 60 degree, it's 1/2. Now, we're almost done. Now we use this information here. So let's go back. In quadrant 1, all trig function is positive, sine, cosine, tangent. Quadrant 2, sine is only positive. Quadrant 3, tangent is only positive. And then quadrant 4, only cosine is positive. Now 120 degrees was in quadrant 2. Since only sine is positive, that means cosine and tangent is negative. Since we're using cosine, our exact value will be negative. So, to review, example 1, first we look for our reference angle. Then, instead of cosine 120 degrees, we wrote it as cosine of 60 degrees. Then when we evaluate for the exact function, we got 1/2 from this table. Then we use the information for the sine, if it's positive or negative. Since it was in quadrant 2 and its cosine, our exact value is negative 1/2. So, cosine of 60 degrees is equal to negative 1/2, or you can also say cosine of 120 degrees is equal to negative 1/2. And that will be our final answer. In our second example, we have sine of negative 135 degrees. Now, to review from 1.1, 1.2, since it's negative 135 degrees, the graph will go clockwise. So starting from the standard position, when it would rotate 135 degrees, so it's mainly going to be either quadrant 4 or quadrant 3, maybe quadrant 2. So let's check. In order to find reference angle, we need to use our positive angle. So since it's negative 135 degrees, what we're going to do is we're going to take away from 360. So we're going to do 360 degrees minus 135 degrees. Again, we're only doing this because reference angles, when we're looking for it, we have to use positive angle, not negative. So 360 degrees minus 135 degrees is going to be 225 degrees. So now I'm going to rewrite it as sine 225 degrees. Alright. So we found our positive angle. Now we're going to use 225 degrees. And we check 225 is more than 90, so it's not in quadrant 1. 225 is more than 180, it's not in quadrant 2. Now, to go past quadrant 3, it has to be more than 270. 225 is less than 270, so it's going to be in quadrant 3. So, it's in quadrant 3. So the rule for quadrant 3 is our given angle, which is 225 degrees, subtracted by 180 degrees. So when we subtract that, that's going to equal to 45 degrees. Alright, so sine of negative 135 degrees is the same as sine of 225 degrees, but can also be written as sine of 45 degrees. Now, keep in mind if it's positive or negative. So, let's go to sine 45 degrees. So here's sine, here's 45 degrees. So it's going to equal to square root of 2 over 2. Now let's double check first before we finalize anything. So 225 degrees is quadrant 3, and negative 135 degrees is the same thing as in quadrant 3. So since it's in quadrant 3, the only function that is positive is tangent. Since we're using sine, then that means that our exact value will come out as negative. So sine of negative 135 degrees or sine of 225 degrees will equal to negative square root of 2 over 2. So we rewrite our final answer, sine of negative 135 degrees is equal to negative square root of 2 over 2. And that will be our final answer. So in this example, we did one extra step. We converted or find the positive angle since we were given a negative angle in the beginning. So we just take away, subtract it from 360 to get our positive angle and use it to find our reference angle, which was 45 degrees. And we use it in sine to find our exact value. And we use this table to determine if it was positive or negative. And our final answer was sine of negative 135 degrees is equal to negative square root of 2 over 2. Alright, example 3, we have tangent of 630 degrees. Now, what's different about this one is that our given degrees, or given angle, is more than 360. So, how can we find our reference angle? Well, if we go back, if we do one full cycle, it's 360 degrees. So if I do another 3 cycle, I'm back where I started. So if I do another 360, I'm back to where I started. But, so say I do 360 degrees, but plus 90, I'm up here now. So 360 plus 90 is 450 degrees. So to review, 450 degrees is equivalent to 360 plus 90. Well, that's just basically the same thing as starting from the beginning and then rotating 90 degrees. So basically, the only difference is 360 degrees. So what I mean is, here, our given angle, 630 degrees. What we're going to do is we're going to make it smaller by taking away 360 degrees from 630. Doing so 630 degrees minus 360 degrees will be 270 degrees. Alright, now, so what I mean by 630, so let's go back. So, starting from the standard position, if I do 360 degrees, which is right here, and had I add 270 degrees, I will stop right here. So this is equivalent to 600 degrees. So 600 degrees, I do one full cycle, one full circle, and then I rotate 270 degrees. So we know it's 360 plus 270, so meaning 360 then 270. It's the same thing as 630 degrees, and it will end up at the same place. So if it's more than 360, what you're going to do is you're going to subtract by 360 to make it smaller. And if it's less than 360, then you can stop there. If it's not, then you got to continue until it's smaller than 360. So tangent 630 degrees is equivalent to tangent of 270 degrees. Now, how can I find tangent when we're only doing 0, 30, 45, 60, 90 degrees and we're using reference angle? Now, in order to do reference angle, it's an acute angle. So here's the situation. 270 is exactly between quadrant 3 and quadrant 4. So there is no rules to follow if it's exactly at 270. Same thing as if it was exactly 180, 90, 0, or 360. So what we're going to do is use the corner point here, which is 0, -1. Now if we tie back to cosine and sine, we know that cosine is the x value and sine is the y value. So how are we going to evaluate tangent of 270 degrees? Well, as before I mentioned, the definition or the identity of tangent is equivalent to sine. Now since it's 270, I'm going to write sine of 270 degrees over cosine of 270 degrees. So while evaluating that, okay, so we're using this information here. Sine of 270 degrees, so sine is -1 over cosine is x, so that's 0. Now, here's what I noticed. I have a 0 in the denominator. So when you have a 0 in the denominator, that can only mean one thing. It's undefined. So, when you have a 0 in the denominator, it's undefined. Same thing as how I put undefined for here. When tangent is 90 degrees, it's undefined. So, let me rewrite. Tangent of 600 degrees is undefined. And let me box that up. To review, since we started off with a given angle that's more than 360, I subtracted by 360 to make it smaller. Since 270 is smaller than 360, then we could try to find our reference angle. Now, again, we could not find the reference angle because 270 was exactly on the borderline between quadrant 3 and quadrant 4, so we used a coordinate point instead. This coordinate point came from the unit circle. So cosine was 0, which was in the denominator. Sine was -1, which was in the numerator. But since 0 is in the denominator, it's undefined. So tangent of 630 degrees is undefined. In our fourth example, we have sine of 5 pi over 3. So, in order to check if it's in quadrant 1, 2, 3, or 4, we have to check where this is located, which one is more than, less than the intervals for quadrant 1, 2, 3, and 4. So, typically, I would check with pi first. So, we have 5 pi over 3. Now, if I use pi, which is right here, 180 degrees, so pi, and convert that to a fraction, and have same denominator, which is 3 pi over 3. If I compare 3 pi over 3 with 5 pi over 3, it's more than 3 pi over 3. So therefore, 5 pi over 3 is more than pi. So it's going to be more than 180 degrees. So it won't be in quadrant 1, it won't be in quadrant 2, but it could be in quadrant 3 or quadrant 4. Now, how can I tell if it's in quadrant 3 or quadrant 4? Next thing, I will check this interval right here, which is 3 pi over 2. Now, here's the thing. This one is different denominators. So what would be in common between 3 and 2? Which is 6. So, this is what I would do. To get same denominator, to check if 5 pi over 3 is more than or less than 3 pi over 2, which is equivalent to 270 degrees, I'm going to multiply this one, or give an angle, by 2. The reason is, I want to get a common denominator, which is 6. So, this will become 10 pi over 6. And then, for this one, since it's denominator 2, I'm going to multiply top and bottom by 3. By doing so, that will be 9 pi over 6. So, 10 pi over 6 is equivalent to 5 pi over 3. If I compare it to 9 pi over 6, which is equivalent to 3 pi over 2, I notice that 10 pi over 6 is more than 9 pi over 6. So, that means that our radian is going to go past 3 pi over 2, so it's going to be in quadrant 4. So, we know that it's going to be in quadrant 4. So, Q4, the rule for Q4 is 2 pi minus angle theta. So, 2 pi minus 5 pi over 3. So, since we have 2 pi, basically a whole number, and we subtract it by a fraction, what I'm going to do is I'm going to convert it to the fraction and then try to get same denominator. So 2 pi is equivalent to 6 pi over 3, and it's being subtracted by 5 pi over 3. So that is going to become just pi over 3. So sine 5 pi over 3, basically we're evaluating as sine of pi over 3. Now, in the previous video, I mentioned to make sure to memorize your degrees and your radians equivalency. So, 5 pi over 3, that's equivalent to 60 degrees. So, if I go to sine of 60 degrees, which is equivalent to pi over 3, so our exact value is square root of 3 over 2. Now, we got the exact value, but we need to check if it's positive or negative. Since we're in quadrant 4, the only one that's positive is cosine. Since we have sine, this will be negative. So, we found which quadrant it was in, we found the reference angle, we evaluated, and we got negative square root of 3 over 2. So, our final answer is sine of 5 pi over 3 is equal to negative square root of 3 over 2. So that will be our final answer. Alright, in this example, we're going to check 13 pi over 3 and which quadrant it is. Now, following the rules for radians, the intervals on how to determine which it is, if it's in quadrant 1, 2, 3, or 4. Now, typically in my experience, I look at the numbers, 13 over 3. We know that 13 is way bigger than 3. So this is what I'm going to do. First, I would check with the whole numbers. So in this case, since we're in radians, first thing I want to check with pi. 180 degrees. So what I would do is convert it to a fraction and then get common denominator, which is 3. So that's equivalent to 3 pi over 3. Alright. Next, we see that 13 pi over 3 is more than 3 pi over 3. I'm going to use 2 pi. Now, it might seem like more work, but if 13 pi over 3 is less than 2 pi, then that means it's either between quadrant 3 or quadrant 4. So I'm changing to a fraction and then get common denominator, which is 3. So 2 pi is equivalent to 6 pi over 3. Now, looking at this, 13 pi over 3 is more than 6 pi over 3. So for sure, it's going to go beyond quadrant 4. So it might go to quadrant 1, quadrant 2, or maybe overextend its angle into quadrant 3. We don't know. So this is what I'm going to do. So it's kind of like degrees. If it's going to be more than 360, like 720, and so on, it's going to keep increasing. So since 13 pi over 3 is more than 2 pi, let's check if it's more than pi, meaning since this is pi, 2 pi, 3 pi. So again, if I start from the beginning 0 and I rotate to 180 degrees, which is pi, then another one, which is 2 pi, if I do half a circle again, that's going to be 3 pi. If I want to do 2 full circle, that's going to be 4 pi. But here, change it to a fraction, multiply by 3, that's equivalent to 9 pi over 3. Definitely more than 9 pi, but let's check if it's more than 2 full circles, which is 4 pi. So 4 pi is basically 2 full circles. 2 pi is just 1 full circle. Multiply by 3. So that is basically 12 pi over 3. Looking at this, 13 pi over 3 is 1 more than 12 pi over 3. So basically, 13 pi over 3 was more than 2 full cycles, more than 4 pi. So, since it's more than 2 full circles, meaning it's going to go beyond quadrant 4 and maybe in quadrant 3. So, how are we going to find a reference angle? So this is what we're going to do. We did check pi, 2 pi, 3 pi, 4 pi. Now, we need to make it a smaller angle in order to find a reference angle. So, I don't have to do all this work again. We can just use 4 pi to get a smaller angle. So, what we're going to do is we're going to do 13 pi over 3 subtracted by, instead of 2 pi, which is 360 degrees, we're going to subtract by 4 pi, just like how we did in degrees in example 3. Given that it was 630 degrees, we subtracted by 360. Subtracted by 2 pi, we would get a smaller angle, but we still have to continue to get a smaller one, so we're going to do 4 pi instead. Now, we already did the equivalence, 4 pi with a denominator 3, so it's going to be 13 pi over 3 minus 12 pi over 3. Since we did the work here, which is basically pi over 3. So, why did I do 4 pi? It's because you're going to end up doing the same work. But, hey, let's do 2 pi just to make sure. So, 13 pi over 3. Now, 2 pi is equivalent to 6 pi over 3. So, minus 6 pi over 3, which is 7 pi over 3. So that's still more than 2 pi, which is more than 6 pi over 3. So I'm going to subtract 2 pi again, or its equivalent, 6 pi over 3, which is pi over 3. So we still end up with the same thing, but I used 4 pi or 12 pi over 3 because it was less work. But you can still do the same thing and you still end up with the same answer. But our reference angle is pi over 3. So, since that's our reference angle, so it's going to be cosine of pi over 3, and it's in quadrant 1, so let's see, cosine of pi over 3, that's equivalent to 60 degrees, so if we do cosine, that's 1/2. And since it's in quadrant 1, meaning all trig function, sine, cosine, and tangent is positive, since we have cosine, it's going to be a positive 1/2. So we don't have to worry about any negatives. So therefore, cosine of 13 pi over 3, the exact value is 1/2. So that will be our final answer.